let us go to the another important aspect, atomic models. From our previous discussion, it is concluded that atom is the smallest particle of matter. Atom contains subatomic particles like electron, proton and neutron. Now the question is how these fundamental particles are arranged in an atom. That is the question, because these fundamental particles, electron, proton, neutron, are having different masses and hence charges. Therefore, how these are arranged in an atom, that is the question. For solving this, we have to know about the atomic models. Atomic model is the description of depicting the arrangement of various fundamental particles inside the atom. The various atomic models, these are introduced by time to time, are: the first one is Thomson atomic model, second one is Rutherford model of atom, third one Bohr model of atom, and similarly so many different scientists are given their own atomic models. So therefore, atomic model is a description of arrangement of these fundamental particles of atom in matter. So this is about the atomic model. So let us see the first of all the Thomson atomic model. This Thomson atomic model, J.J. Thomson in 1898 proposed this atomic model. According to Thomson, atom is spherical, and also according to this J.J. Thomson, an atom contains negatively charged particles called electrons uniformly spread inside a sphere of thinly spread mass of positive charge. So this is the atomic model proposed by Thomson. So let us see the J.J. Thomson atomic model. This is the J.J. Thomson's atomic model. This is an atom, and this atom contains positive charge. This is the positive charge. The sphere is positive charge, and the electrons are spread uniformly inside the sphere. These are the electrons. Look at this. This is the model given by J.J. Thomson. This model has been called by different names such as watermelon model, plum pudding model, or an apple pie model. So these are the alternative names of the J.J. Thomson's atomic model. Why this model is called a watermelon model? Because if you observe this watermelon, look at this watermelon, there is some similarity between the J.J. Thomson atomic model and watermelon. So look at this red color pulp is the nucleus, and the electron are represented by the seeds. So therefore there is some similarity. Hence this J.J. Thomson atomic model is called watermelon model. The total positive charge of the sphere, this positive charge of the sphere is equal to the total negative charge of the electrons, and for this reason the atom remains electrically neutral. So here this is the positive charge. The negative charge are treated as the electrons. So therefore these are inside this. For this reason they remains neutral. Thomson model could successfully explain the electrical neutrality of action. We have discussed about this previously. This is the Thomson model explains electrical neutrality of the atom, but it suffers from limitations. These limitations are, let us see, the model could not explain how the positively charged particles are shielded from the negatively charged particles without getting neutralized. This positive charge and inside this electrons are present. There is some attraction between these two, so that these electrons may come close to the nucleus, so matter should be collapsed, but the atom is stable. Here a valid explanation was not given by the Thomson atomic model. In order to rectify these defects, after J.J. Thomson, Rutherford carried out a series of experiments from 1905 to 1911 to test the correctness of Thomson's atomic model. Ernest Rutherford in 1911 gave the concept of nucleus based on the results of his experiment known as alpha ray particles scattering experiment. So based on this experiment, Rutherford gave the concept of nucleus. Let us see Rutherford alpha ray scattering experiment. To carry out this experiment, he takes alpha particles. These alpha particles are produced from a radioactive element. So look at this this is a radioactive element. This radioactive element produces alpha particles. That means the alpha particles are allowed to incident on a thin metal foil. This metal foil is generally made up of gold. Therefore, Rutherford bombarded a thin gold foil with alpha particles. The foil was surrounded by a spherical screen of zinc sulfide. The alpha particles were condensed to a narrow beam by passing through a pair of positively charged plates. So here, these positively charged alpha particles coming from a radioactive element will fall on the metal foil and gets scattered in different directions. Out of these radiations, look at this. The important observations of this is, most of the alpha particles pass through the gold foil without any deflection. Another observation is, a few particles were deflected through small angles and few were deflected through large angles. And another observation is, very few, that means 1 in 20,000 particles were completely rebounded. So these are the three aspects which we can observe in alpha ray scattering experiment. On the basis of these observations, Rutherford concluded that Thomson atomic model could not be the correct because of the following reasons. The reasons are, most of the alpha particles pass through the gold foil. This proves that atoms must have large empty space. So that means, based on this experiment, he proposed the model of the atom. In this model of the atom, how these particles are arranged? So let us see. Most of the alpha particles pass through the gold foil. So that means, what we conclude is, most of the space inside the atom is empty. This is the immediate conclusion. Next one is, since very few particles completely rebounded, he concluded that the total positive charge of the atom is concentrated at the center of the atom, because the incidenting particles having positive charge. So therefore, the nucleus is also having positive charge. Complete rebounding takes place when the particle strikes exactly at the center of the nucleus. Look at this. When the particles strikes exactly at the center of the atom, it completely rebounces. The tiny central positively charged core was named as nucleus. This central part is known as the nucleus. The large deflection of the alpha particles could take place only because of the close encounter of the alpha particles with the central positively charged core, that is the nucleus. Why the deflection? Some are getting deflected through some angles and some are largely deflected. This deflection in alpha rays is due to the striking the alpha particle some portion of the nucleus, hence it causes deflection. Rutherford proposed a model that is called the Rutherford model of the atom. From this, he calculated the diameter and the radius of the atom. Rutherford estimated the diameter of the nucleus to be the order of 10 power minus 13 centimeters and that of the atom to be 10 power minus 8 centimeters. So these are the estimated values of Rutherford of an atom and the nucleus. Thus, the diameter of the nucleus is about 10 power 5 times smaller than the diameter of the atom. Now coming to the actual picture of the Rutherford's atomic model. The important points in this Rutherford model is, atom consists mostly of empty space. And the second one is, the entire positively charged particles are present in the center of the atomic sphere. This concentrated positively charged mass within the atom is called the nucleus. So here this is the atom, and here this space represented here, it is the empty space, and the mass is just concentrated only at its center. This center is called the nucleus. Look at this center. This is called the nucleus. Now, the size of the nucleus is very small compared to the size of the total volume of the atom. So look at this. This is the big atom, and when you consider this nucleus, this is very small when compared with the atom. Next one is the electrons within an atom must revolve around the nucleus at various distances at very high speeds in order to counterbalance the electrostatic force of attraction between the protons and electrons. Now coming to the part of the electrons, we have accommodated the nucleus. Now the electrons, what is the position of the electrons in the Rutherford atomic model? These electrons are moving around the nucleus at various distances with a high speed so as to balance the electrostatic force of attraction between these two. So to balance these forces, because the nucleus is carrying positive charge and the electron is carrying a negative charge, definitely there exists a attraction force. So in order to balance this attractive force, electron is moving with a high speed in the definite path. How this Rutherford model of the atom is look like? This Rutherford model of the atom is very much similar to the planetary model or the solar system. Rutherford atomic model can be compared with the solar system. How the solar system is? The planets are revolving around the sun. In a similar way, the electrons are also moving around the central positive charge, that is called the nucleus. So here when you compare these two, that means the planetary model and the Rutherford model, here the nucleus is same as that of the sun, and the planets, Earth, Jupiter, all these planets will be similar to that of the electrons. Hence the Rutherford atomic model is also known as Rutherford planetary model. Drawbacks of this Rutherford model. Rutherford model could not explain the stability of an atom because the electron is a charged particle moving around the oppositely charged nucleus. Yes, we know that the electron is having a negative charge, and according to the Rutherford model, electron is moving around the nucleus in fixed paths. According to the classical electrodynamics, an electrically charged particle revolving around in a circular path radiates energy continuously. We know in physics we have the electrodynamics. Whenever a charged particle is moving around the nucleus, definitely at any cost it will loses its energy. At any cost it will be fall into the nucleus. Now look at this animation. Here this is the electron which is moving around the nucleus. So when this electron is losing energy continuously, it fall into the nucleus. The atom should be collapsed. But it is not taking place, but the atom is kept stable. That means this anomaly cannot be explained by the Rutherford. Hence, an electron revolving around the nucleus, because of the attractive force between these two, the electron gives a spiral path for the electron, which should finally collide with the nucleus, and the atom would collapse, but atoms are quite stable. But the atom is stable. So this cannot be explained by the Rutherford model. So these are the some limitations or drawbacks of Rutherford atomic model. Based on this knowledge, we try to solve some model questions. Look at the first question. Rutherford's experiment, which established the nuclear model of the atom, used a beam of. Here are the options. The first one is beta particles which impinged on a metal foil and got absorbed. Second one is alpha rays which impinged on a metal foil and ejected electrons. Third one, helium atoms which impinged on a metal foil and got scattered. And the fourth one is helium nuclei which impinged on a metal foil and got scattered. In Rutherford experiment, Rutherford used a beam of alpha particles. These alpha particles are treated as helium nuclei. So therefore, these are 2He4. Hence, the correct option is 4. Next question is, in Rutherford alpha ray scattering experiment, gold foils are used due to? Here are the first two options. The first one is high malleability, second one ductility, third one high melting point, and fourth one high ionization energy. So in Rutherford alpha ray scattering experiment, gold is used as a metal for scattering. This gold is having high malleability, so it can be easily made into a thin film. So we need the thin film, so for this purpose only this highly malleable element, that is gold, is used. Hence the correct option is 1. Next question is, which of the following is true for Thomson model of atom? Here are the options. The first one is the radius of an electron can be calculated by using this model. Second one, in an undisturbed atom, the electron will be at the equilibrium position where the attraction between the cloud of positive charge and the electron balances their mutual repulsion. Third one is atom contains positive charge at its center, and fourth one is none of these. If you know the Thomson atomic model, then we can easily answer this question. So look at this. According to the Thomson, the electron will be present at their equilibrium position. At this equilibrium, the attraction between the electron and positive charge is balanced by the mutual repulsion of the electron. To understand this, let us consider the Thomson atomic model. This is the Thomson atomic model. Look at this. This positive sphere is the nucleus. This circle is denoted or called the electrons. Here at the equilibrium position, here positive charge and negative charges are there. The repulsion between any two electrons will be exactly balanced by the attraction between the electron and the positively charged sphere. So this is the condition for maintaining neutrality and equilibrium in J.J. Thomson atomic model. Hence, the correct option is 2. Next question is, the best evidence that electrons are arranged in definite orbits or energy levels is based on the observation that, here are the first option, atomic spectra, which consists of discrete lines and not continuous bands. Second one is, electrons in the beta ray have high kinetic energy. Third one, the penetrating power of cathode ray electrons depends upon the voltage used to produce them. And the fourth one is, electrons revolve around the nucleus. Here, the atomic spectra, which we will discuss in the next subsequent classes, this atomic spectra is the best evidence that electrons are arranged in definite orbits. Hence, the correct option is 1. Next question is, the conclusion of Rutherford scattering experiment does not include. Here are the options. The first one is, alpha particle can come within a distance of the order of 10 power minus 14 of the nucleus. Second one, the radius of the nucleus is less than 10 power minus 14 meters. And the third one, scattering follows Coulomb's law. And fourth one, the positively charged parts of an atom move with extremely high velocities. According to the Rutherford model, the positively charged part of the atom called the nucleus, which is at the center. But in the given options, the positively charged part of an atom move with extremely high velocities. So that means this is not included. Hence the correct option is 4. Next question is, Rutherford scattering experiment is related to the size of. Here are the options. The first one is a nucleus, second one atom, third one electron, and fourth one neutron. So in discussing the Rutherford scattering experiment, we have arrived the size of the nucleus. Therefore, Rutherford scattering experiment is particularly related to the size of the nucleus. Hence the correct option is 1. Next question. When alpha particles are sent through a thin metal foil, most of them go straight through the foil. This is because of. Here are the options. The first one is, alpha particles are much heavier than electron. Second option, alpha particles are positively charged. Third option, alpha particles move with high velocity. And fourth option, most part of the atom is empty. Yes, this is the observation made by the Rutherford. most of the alpha particles are passing through the metal foil. This is because the alpha particles go straight because most of the space inside the atom is empty. Because of this empty space, the particles are going straight. Hence, the correct option is 4. The next question is, Rutherford's alpha ray scattering experiment eventually led to the conclusion that, here are the options. The first one is, mass and energy are related. Second one, electrons occupy empty space around the nucleus. Third one, neutrons are buried deep in the nucleus. And fourth option, the point of impact with the matter can be precisely determined. This Rutherford alpha ray scattering experiment reveals that the position of the nucleus and the fundamental particles, that means electron, proton and neutrons. So here the electrons are revolve around the nucleus in the empty space. This is the position of the electrons. Hence the correct option is 2.